Okay, let's carry on with our revision on the chapter of pressure. We talk about Boyle's law. Okay, what is Boyle's law? Okay, Boyle's law, okay, is basically saying that pressure is inversely proportional to the volume. Okay, so for example, you have a gas or a liquid. It's actually quite commonsensical, right? That the smaller the volume, the greater the pressure. Okay, if the volume increases, then the pressure goes down, right? Sounds commonsensical enough, right? So we always associate this formula with it. P1 V1 equals P2 V2, right? So now, okay, you might have forgotten what is 1 1, what is this 2 2 thing? What is this strange formula to use? Okay, and try to help you remember when I taught you, I told you, okay, 1, what does 1 mean? 1 is like situation 1, okay, in a question, and then 2 is situation 2. And then from this, you can help you find the pressure, let's say in situation 2 or situation 1, right? Okay, the best thing is, of course, to look at an example when we to use this formula. Okay, just to look at one quick one in case you have forgotten, right? So you have done this before, maybe you have forgotten how to do this, right? Maybe you want to pause the video or look at your worksheet here, try to see whether you can remember how to do, all right? Okay, now read the question very carefully, right? So it says here is 3 cm cube of air inside here, and here there's a certain volume, we don't know what is it, right? And then, so this is like situation number 1, right? You have this situation here, and then after that, they added in more mercury such that it becomes situation number 2, right? So identify your two situations, right? Read carefully the question, then you see, okay, over here is at first 3 cm cube, so you can write there 3 cm cube. And then what's the pressure over here? Okay, now what's the pressure over here? There's air. Don't think there's nothing here. There's air, right? They say there's air, so air is trapped here. So this is a pressure of air over here. So again, you label what you know. Pressure air. What do you know? Open to the this tube is open to the surrounding. So this is atmospheric pressure, right? So pressure air. This is atmospheric pressure. Okay, you label what you know, and then I think you can see they are same level. They are the same pressure, that means, right? That means here pressure air is equals to the atmospheric pressure. So you can say that in this situation, here is atmospheric pressure, right? And what's the atmospheric pressure? They say 76 cm of mercury. Okay, so I can write there 76 cm Hg, right? Okay, so come to this situation. Okay, so they added more mercury, and so this volume got compressed. So I think you can already know that if this volume got smaller, that means the pressure here is more. Okay, but still, how do you do, right? So you want to find out, okay, what is this pressure over here? This is, you can call it P2, right? What is P2 over here? Then you look over here, same level, here is also P2. What is P2 due to? So back to the same property, you must always remember, same level, same pressure, same liquid, of course. And then look up, what's above? 76 cm of mercury. That's not all, right? Don't forget, there's something you can't see, but it's acting on it. There is also atmospheric pressure acting here, right? So there's atmospheric pressure, there's this amount of mercury, right? So that is the pressure that's acting here, which is the pressure here, right? So over here for P2, I can write there, right? 76 cm Hg plus the atmospheric pressure. So 76 cm Hg plus the atmospheric pressure, which is also 76. So I can write 76 plus 76. And then I can get right there V2, which I want to find. Okay, so this is how you will use this formula, okay, this relationship, Boyle's law, in order to find the volume here, right? So the key thing is read the question carefully, understand it, try to find out like situation number 1, situation number 2, okay, or you can think of it as like before and then after, okay, before I had this, after when I add mercury, what happened, right? You try to identify the P1s, the V1s, and so on, and then from there you solve, okay? So do practice, right? Because often this poses quite a problem for students, right? Boyle's law, huh? Okay, so do have a look at your questions and practice more on this, okay? Let's then do the next thing about the last, probably more important thing about pressure, okay, is hydraulics. Okay, so how do hydraulics work? Okay, so how do hydraulics work? Okay, hydraulics are not very difficult to understand, right? They are like force multipliers, right? So over here, simple hydraulic system, right? Over one side, you got piston A, right? The smaller one, right? Piston A, right? So let's call this A, and then over this side, B, right? So they are force multipliers in that sense, right? So the key thing here to remember is this, for hydraulics. Okay, the pressure that is exerted here, okay, you push down here with a force, and because of this area, there is going to be a pressure. So this pressure at piston A, right, will be transmitted throughout the liquid, and it will equal to piston B over here, right? So that is the key takeaway, right? How hydraulics work. Okay, and then piston A, you can of course write the formula, force over area of A, then this will be force of B over area of B. Okay, so because this is a few times bigger than this, it will then multiply the force, okay, such that whatever force you apply here is multiplied and can lift up something which is of a greater weight, right? So that's how hydraulics work, right? And they are very efficient. Why? Okay, there's hardly any energy loss, okay, because it's all liquid, right? And there's hardly any frictional forces here. Okay, okay. The next thing to remember is this also, of course, that law of conservation of energy applies. That means the work done you do at A. So when you push down at A, the work done at A, right, is equals to the work done at B. Okay, so the work done at B. So you push here, work done at A equals to work done at B. So again, you remember the formula for work done, force times distance, right? So the force you apply at A, the distance, this moves down, okay, at A will be equals to the force that applies at B, and the distance, it moves out at B. All right, so maybe you can't see, okay, a bit low. Right, so this was the idea about hydraulics, right? So you look at examples of hydraulics, okay, they are not very difficult, okay, over here. So for example, with this question, your worksheet you did, okay, so you put a force of 1,500 at A, okay, then if you know the cross-sectional area is here is 0.2, you can find the pressure 7,500. So this 7,500 pressure is transmitted throughout the liquid. It acts over here at a load L, and then you want to find how much force it can exert on the load, okay, then simply use the formula again, right? And there you go, right? Not too difficult, okay? I think you should be able to understand this, all right? So to again revise, right? Don't take things for granted, huh? Okay, now let's just look at one example, okay, as we do revision, right? Again, look at this question over here, okay, just to remind you, okay, how you did this last time, right? So this is a typical question you can get, right? So find the atmospheric pressure, okay, you look at the two situations we have, okay, one barometer is vacuum, one has air, right? So again, obviously we look at the one that is a vacuum to find the atmospheric pressure, okay? So again, I label already. Atmospheric pressure is here, so here is also atmospheric pressure. So then look up, what's above? 72 cm of mercury. Vacuum, no pressure, right? So answer is 72 cm Hg. Very straightforward. Okay, then this one, sometimes this causes a problem, this part. Calculate the pressure exerted by the air over here. Okay, so how do you do it? Okay, I hope you don't just guess your way. Okay, oh, 72 minus 60. You got 12. Okay, that's the correct answer, but you may not know why, right? So again, let's go back to thinking how we can form a relationship. First, before we do that, label. Over here is air. So here is the pressure of air, right? So I can label here pressure of air. So this is a pressure of air. Then over here, atmospheric pressure, right? So atmospheric pressure. Okay, how are these two related? So this atmospheric pressure is due to whatever that's above, right? So it's due to whatever above. So what do I have above? 60 cm. 60 cm of mercury plus the atmospheric, plus the pressure of air, right? So 60 cm plus pressure air. That's why I write it as this way. Okay. Don't make a mistake and say 60 cm of mercury plus 15 cm of air. That's wrong. Okay, so this is the way you should write it. Okay, the relationship. Okay, so that was just one quick revision on a question. All right, and then of course, okay, this question is very worth revising. This part over here, right, part B, where they ask you, okay, what happens when tube Q is pushed down. Okay, many students don't realize this is actually a case of Boyle's law. So your situation is what? Situation is here before you push it down, right? You have a certain pressure, you have a certain volume, right? Then after that, you push it down 10 cm. So you push this down 10 cm, you can imagine this will become smaller, right? The pressure changes, you can call it P2, okay, right? And then the height now they tell you is 10 cm, right, from the question, okay? So from there, okay, you apply Boyle's law, right? So situation 1, okay, 12 cm of H, 12 cm Hg is the pressure acting here. The volume 15 cm times A. A is what? Cross-sectional area, right? Then over here, pressure 2, okay, here is P2, right, is 10 times cross-sectional area A, right? So that's how you form the relationship, okay, of the and use Boyle's law to help you solve this question, okay? So it's again worth revising through, okay, looking at how you problem solve, right? Okay, I think I will just end the revision here. Do have a look at other types of question, okay? This is not all, so you have to revise through everything by yourself. Okay, I think I'll just do a quick revision on this, because this doesn't always come out, but when it comes out, sometimes it causes a little bit of problem for your students. Okay, so you have a tube here. Okay, in this tube you have air that's trapped inside this tube, and there's a column of mercury here, right? So you have three situations. One, this tube is lying sideways, right? This is in this situation, okay, when it's somewhat upside down, and this is this way, right? When it is open to the top, right? Okay, so when you are given this, okay, the approach is what? See where atmospheric pressure is acting. Okay, so here atmospheric pressure is acting in this position, right? Atmospheric pressure acts in all directions, so it can act sideways as well, right? Now does this mercury column exert pressure here? The answer is no. Why? Because the weight of this mercury is acting down, so it does not affect the pressure of air here. So in this case, you can simply say the pressure air is equals to the atmospheric pressure, all right? So looking at, okay, maybe you look at this one first. This is easier. So this pressure air over here, what is it dependent on? Again, the approach is find out where the atmospheric pressure is acting. Okay, atmospheric pressure is acting down towards here, right? Acts in all directions. So it's open, it's acting downwards here. So this is acting down. This mercury column is also acting down on the air. So you got, remember what we always say, pressure is always due to what is above, right? So what is above? You got the mercury and the atmospheric pressure. So you can say this pressure air is equals to the H cmHg, this height of mercury, plus the atmospheric pressure that's acting on it, right? Okay, then how about this, right? This case, right, the atmospheric pressure is acting upwards, right? Acts in all directions, acting upwards. The mercury is acting downwards, right? So it's coming downwards. So what is this pressure due to? All right, this pressure air due to, right? So maybe you can see it this way, that atmospheric pressure acting upwards is equals to everything here that's above it. So HCmHg again plus the pressure of air, right? So that's how you get the relationship. Okay, the key thing is this, to know one, the atmospheric pressure is acting in all directions, this way, this way, this way, right? And then this mercury is always, the weight of this mercury is acting down, okay? And so the pressure might be, the pressure is acting down here at this point, okay, and acting down, and here's acting down, right? So even if you are given a situation where it is like this, right, like this, okay, terrible drawing, okay, pressure of air, right, where's the atmospheric pressure acting? It is still acting this way, right? diagonally even, right? And then this mercury column might have a pressure that's acting here, like down this way, right? So in this case, okay, this pressure of air, okay, compared with this would be lesser, right? Because this is not acting directly upon this air that is trapped inside here, right? Okay, so this is acting directly down. Okay, so do bear this in mind. Okay, this can help you in doing some problem solving as well. All right. Okay.